orthographic projection of lines inclined to both a plane. Actually, we can reach the inclination to both the plane in 3 stages, 2 ways. Parallel to both the plane, inclined to HP, then inclined to HP and VP, or parallel to both the plane, inclined to VP, then inclined to VP and HP. So both the way we can reach the double inclination. Depends upon the available data. Or if enough data are there, we can draw directly inclined to HP, then HP VP, or directly inclined to VP, then HP VP. Both are possible when solving the double inclination of lines. But for our study purpose, we will take from line parallel to both the plane, then inclination to HP, then inclination to VP. So AB becomes AB1 stage and AB2 will be the third stage. So B becomes B1, that is makes inclination only to HP. This is what we studied in earlier slide, and the conclusion were drawn, and we call it as rule 3 and rule 4 for inclination to VP. So 3-dimensional view you can closely watch, and inclination to HP 28 degree for this problem, which is visible in the front view. True length is 60 mm, but projected length will be less than that one. Now the top view, you can see AB1 is parallel to XY. Now take a line AB parallel to both the plane is rotated in such a way that it is inclined to VP only. First stage was inclined to HP only. The second stage is inclined to VP only. So we have overlapped both the stages together in this diagram. And rule 3 and rule 4 can be recollected. And in the plan, it's true length AB2 space AB2, capital AB2 is equal to plan small AB2. And front view is projected length, that is A dash B2 dash is a shortened length, but it is parallel to XY. So rule 3 and rule 4, which we have concluded from the earlier projection of right inclined to HP and VP, are overlapped here. That's all. Note down the shortened length A dash B2 dash, and AB1 is the shortened length when line is inclined to HP only. But AB1 is parallel to XY, A dash B2 dash is parallel. Both are 2 stages. So it is always better to draw individual inclination, because we have to draw the log. So it is mandatory that we have to draw 2 inclinations separately, so that we can find other required points or locus to draw the double inclination. But before completing this double inclination, we should be aware of that when the line is inclined to one plane, that is here it is inclined to HP only, when it is rotated in such a way that make inclination with VP, actually it is moving or tracing a surface of a cone, that is generator. Each stage is nothing but the generator of the surface of the cone, so that it can maintain inclination with the HP as well as we can record the inclination of the VP. So if you take the surface of the cone, each generator will have some constant inclination, which is nothing but the complementary half cone angle will be maintained same with respect to HP, but VP it will be gradually, it will be varied. The generator maintains the same angle. So likewise, imagine another cone which axis is perpendicular to this one. This one means it's perpendicular to VP. Earlier one was perpendicular to HP. So the generator of this cone is nothing but, actually it maintains some constant angle with respect to VP, but the generator of the cone varies with respect to HP. So inclination will be varying. So the common generator between these two cones, which has been drawn for particular off cone complementary angle, will be the line inclined to both the plane. So the cone generator maintains angle with the plane where its axis is perpendicular to the plane. So now it is perpendicular to VP, so angle of inclination will be VP will be same, but HP will be varying if you take a different generator on the surface of the cone. Now with this concept we will move on to line inclined to both the planes. So this common generator is nothing but line inclined to both the planes. Now if you remove the rest of the surfaces, that is stage line inclined to HP, it becomes line inclined to VP, or inclined to VP then inclined to HP. So both will be reaching the same point. It is B3, the stage B3 inclined to both the plane. B1 to B3 or B2 to B3 will be the same, and you can understood by seeing the dimensions of the cone. That is actual or true length is visible in the front view and visible in the top view for a line which is parallel to XY, but even AB3 also has the same length, because these are lines in the space made inclination. But in orthographic projection, because of the convention followed, it looks as if it is shortened. See the length, true length, when it is parallel to VP, at the time also 60, when it is parallel to HP, at the time also 60, and when it is inclined to both the plane in space, the length is same, that is AB3 inclined to both the plane. The common generator is also of 60 length, but because of the orthographic conventions followed, the projection of a line inclined to both the plane looks as if it is shortened in the vertical plane as well as in the horizontal plane, but actually in space all are of same length. You see the inclination with the HP is 28 degree. The line only, the true length is visible. So true length and true inclination is visible in the VP. Likewise, true length, true inclination in the HP is 45 degree. But when it is projection two-dimensional paper, we can see only when in the our true length is available. But now look, a common generator. So the radius of this sector of the cone follows that projected length. Though we don't need, only we can visually see only in this three-dimensional drawing. So when you look from the top, it's a straight line. Now see the angle between the common generator, which is line inclined to both the plane and the VP, that is 45 degree is visible. This can be visualized only in 3D. So the common generator is inclined to VP 45 degree, and this common generator or the line inclined to both the planes makes inclination of 28 degree with HP. So this is the inclination with HP and that is the inclination with VP. This is the beauty of visualizing the inclination in SOLIDWORKS. So same thing will be applied whenever a line is inclined to both the plane. And its projection B3 front view of that line, we call that as A dash B3 dash in elevation or in front view, that is shortened line. So A B3 is actually true length in space when it is projected in the vertical plane. Because of the conventions in the orthographic projection, it looks shortened. So A dash B3 dash is shortened length. Actually original length is in space, it is true length, equal to true length. Likewise, a projection in the horizontal plane of a line inclined to both the plane A B3, or here it's a common generator, is A B3. It also looks as if shortened because of the conventions followed. That is, rays are straight and it passes through an object and strikes the plane perpendicularly. That's why it looks as if it's shortened. Thank you. We will continue in next.